which as it turns out is bell-shaped. I did not know that. Did a little research into it. Fun. Back to human pregnancy. Turns out, now this is based on what I saw. There we go. Speaking of being more than one standard, I've read different articles about human pregnancy. Once I found that it was bell-shaped, I'm like, that's cool. So I read up more, and I'm like, wait a minute, this article says that it's a little bit different than that one over there. And this one says it's different than that one over there. But this one says it's the same as this one over here. So finally I decided, okay, let me just take all the values they give me and average them together and see what I get there. And when I did that, I got this. When you average all their values, they tell you, you got an average of about 266 days from conception to birth on average. Now, what unit is very commonly used for pregnancy?
Months.
Months, right? 9 months. 40 weeks, I think, is also used, right? 40 weeks, so what's that? 40 times 7 would be 280 days. It's a little bit longer than that. That's like one of these above that, which is interesting. I wonder if it's a long. I wonder if 40 weeks is like a max.
I think there's a max.
Is it? Is 40?
No.
Oh,
no,
you know what?
They say 38 to 42 weeks, so.
Hold all those points for the question that I've got right here. Believe it or not, I think I just segued my own thing too early. Hold that for here, because I want to explore two concepts of pregnancy. Two concepts. First, the preemies, and then the opposite of preemies, the get them out nows. Okay? So I want to explore both of those. First, the preemies. Now, I had a midwife in class years ago that almost beat the piss out of me one day because I said, here's the definition I've seen for premature births. She's like, that's wrong! I'm like, okay, maybe, but it's what I've seen. So, assuming this definition of premature births, like, okay, I'll let you go with this one. It's like, thank you. Please put the pencil down. So, 5th percentile, the shortest 5% of births. What would that be? What would that be? How many days would that be?
Far out there.
So how far is pretty far? Good. I'm an expectant mother and I'm nervous.
That's pretty damn far.
Again, give me a day. Don't.
Well, I'm just saying, if you think about what 2/3 and 95% is, you know how much that covers?
Good. What does that cover?
Imagine how much more you have to go out. You know what I mean? Like.
So what? Tell me.
235.
235 days. 34. Where'd 34 come from?
Well, 2 standard deviations.
But it's not 2 standard deviations.
Why would
Is it?
It's 5.
Remember, it's the 5th percentile,
Oh.
which means the. Let's draw it. Yes.
Yeah.
Let's draw it. You gotta be careful with the difference between a confidence interval, which is between two values, and this one, which is just one tail. See, here's the deal. Here's the deal. Let's draw a picture. Let's go over that board. Actually, let's save some. Let's not keep up and down on the screen, picking up verbs when I'm tired. There we go. So I'm not the pretty far out there. I gotta quantify. That's all I'm saying is I want to quantify pretty far out there. I want to know how far out there is out there. So here's human pregnancy. It's a timeline. 0 out to, well, I guess theoretically infinite, but I mean, theoretically, not practically. I mean, I don't think you will much beyond. We'll talk about that in a minute. So, but we know that 266 is in the middle of it. So it's got this bell, like this. Average in there. And then we've got standard deviations on that, yes? So that's 0. 1 and -1 would be 282.
Yeah.
Check my math on this.
Yeah.
250.
Yep.
And then 2 would be 16 more. 298.
297.
297. And then down 16 more. 234.
Mm-hmm.
Okay, fair enough. Wait a minute. 298. 16. Should be even numbers. So now we do know certain percentages based on this, yes? We know, for example, how many pregnancies here?
2/3.
Is that fair?
Yep.
2/3?
95%.
95%?
2.5.
2.5?
2.5.
2.5?
50/50.
Good. That's for Austin and me.
25. No. 1/3.
Good! 1/3, right? Because this is 2/3. That's got to be 1/3, 1/3.
16%.
Where'd 16 come from?
It was it last time.
Aha! perfect. So if this is 95%, and this is roughly 67%, we'll make it 2/3, right? So what's 95 minus 67? Was that 28? Is that 28?
Yeah.
So what's this? Half of that, right?
14.
14 and 14. That's a lot of math really quickly there, isn't it? But the problem with that is, all those numbers we just threw around, 14, 28, whatever the hell height, none of it is 5, is it? None of it. Natasha?
So you just work it backwards.
Thank you, sister. We gotta work it backwards, right?
Yeah.
Tell me where to stop. Where the marker has to go in to make 5%. I don't know what the number is, but tell me where I have to stop on the curve. You ready? Bring me.
Like right there.
Done. Good. Throw it up. Now some of you might be, I would have gone a little bit further. That's totally fine. Let's just make it right by doing this. That's 5%. We don't have to draw a perfect scale. All you gotta do is figure out where it is on that scale. And did you hear what Natasha said? Put it there and work it backwards. And it is a backwards problem, isn't it? Because I told you it's 5%. All you gotta do is figure out where the 5% is. So clearly, if we know this is -1 and this is -2, it's somewhere between -1 and -2 on the z-score scale. Our job now is to figure out where on the z-score scale it is. Thank you, sister. Oh, you know it! Let's all do it! Let's all do it. I appreciate that you got it right. Let's make sure we can run this. Because a big part of being able to solve these problems is being able to generate the numbers you need. So, let me see that, I think. All right. Definitely backwards. Natasha, which way did you shade left? I'm assuming.
Yeah.
Shade left, that makes the perfect sense. 5% is a decimal. Here it comes. There they are. They're the preemies. They're the preemies. Just over 1.5 standard deviations down. Wasn't that Phelps in The Fly? I think that was his z-score in The Fly. Isn't that incredible? Same exact z-score. He's down just as much as a preemie birth is down from average. It's all the same. The units are gone. That's why it's kind of comical. It's like, that's Phelps. Yes, but Phelps and the babies are all gone now. This is one curve that stands for all that stuff. Kind of rad, huh? You know, I said it's live. It's okay. So, you now know how many standard deviations you are down? Yes? Can we convert that back to a number of days? Of course you can. Use the same thing we did last time. You know, you just take that z-score, multiply it by the standard, and add the average, and that'll kick you back. You tell the mother, you don't tell the mother you're down 1.64 standard deviations. The mother doesn't care about that. She's worried about her baby. Give her a number. Do it. -1.64. Sigma was 16. Add on the average.
They're at 239.76.
How do we call 240? Sound good? 240 days. Any birth.
4 weeks.
6 days.
26 days.
26 days before due.
30
Right? The average due date is 266, so it's 26 days before that average due date.
Looks like 34 weeks.
So, right, so on average, 240 days is going to be a preemie. Now, of course, births have or pregnancies, I should say, have births do too. Pregnancies have deviations in them. But the idea is, if medical professionals want to apply one metric to what is considered a preemie, this is one way to do it. The shortest 5%. Now you got to remember, and somebody brought this up correctly in the last class, and so did my midwife friend from that class years ago. By the way, I love midwives. We used one. It was a phenomenal experience. I don't know if you guys had any experience with it. There are great variations in the due date assignment, which I'm sure you've heard if you've been involved with this kind of a thing. They tell you your due date is, my guitar player just went through it. He's had a baby last Thursday. Jesse's now 1 week old. He was 7 days overdue. 7 days overdue. That's a
They
week.
could have misjudged that.
Of
You have no idea
course.
what that moment.
Not to mention, where is it? Where is it?
Yeah.
That's over 2 weeks of variation.
Oh my god.
Right? This bell curve is squat and wide. It's really, really wide. 16, 16, 16, 16, 16, 16. All of a sudden you're picking up like a half a month each time, right? That's a wide-ass curve. But that's because it's a wide-ass distribution. There's a lot going on in pregnancy. Lots of little gears turning. Make a little baby. And a human with a tail that goes away eventually. What a shame. Fair? Fair with that? So, 240 is a good cut. Who's heard that for preemies, 240? Or 34 weeks? You did 34 weeks, you just divided it by 7. Mel, you heard?
That's what actually happened with my daughter.
240. Wow. Did you get the preemie talk?
What is that?
Did they say this is a very short pregnancy, or
Oh, no, they
No.
were just like, let's get her out. 'cause
Let's, oh, okay.
It's an emergency zone.
Oh, gotcha. And now that brings up the next point is the let's get them out time, right? So now that's on the other side of the curve. Because you've got pregnancy, right? You've got pregnancy. And these are the really short ones. They're getting longer, they're getting average. Now they're in the oven. Baby likes it in there, doesn't want to leave. At some point, we gotta kick them out. And why do you have to kick them out?
It's too big.
Well, they get too big, right? There's a finite amount of space, and the baby keeps growing, as they like to do. Babies grow in weeds. It's gonna get out because they get too big. If they poop in there, that's really bad. I've been told.
It could hurt either the mother or the child if you
Yes, you could hurt one or both. Yes. So it becomes. We like the baby developing inside because it's like what Mother Nature intended, but there becomes a point beyond which it becomes detrimental. And the reason I bring this up is when Jen was pregnant back in early '07, a lot of the women in my neighborhood and surrounding immediate area where we live were giving birth roughly the same time, and almost every single one was induced. Almost every single one. Like across the street was induced twice. And this was not interrupted, it was just like, okay, you're in too long, pull. Okay, I thought that was interesting. And then down the street, induced, you're in too long, pull. So what question, of course, did I then ask? What's too long? I started asking, okay, maybe Ben does a different definition of too long. Maybe like 3 days past due was like too long. Get him out! So I started asking around, doing some research. What's too long? Anybody know?
I also have to say that some people have their individual.
Oh, hell yeah, they do.
Way too long in my
Get this baby out of here. Let's talk about nature, though, or doctors' best attempt at trying to measure nature. Do you know what the standard is? So they say
2 weeks.
2 weeks is the overriding modal standard that I have seen for as 2 weeks. Get it out.
But
That's what I've heard
not
too.
two standard deviations.
No, it's
The
not.
average.
That's what got me thinking. So I said, you know what? This is a Fun Math 243 problem. Let's do it. Fun Math 243 problem. Let's figure out if we have defined the definition of induce at this point as 2 weeks passed, what percentage of births are going to get induced for natural reasons, or for this reason, not for get them out because I got a golf game to get to or something like that, but because of this. So I guess my question is, what's the chance that a birth is going to last more than 2 weeks than its due date? Well, we have the tools now to answer that. Don't we? We got the curve already. The curves are there waiting for us.
16%.
Yeah, let's take a look. Yeah, swing over to here. I think we have the tools. I think we can. It's that curve, yeah. We'll get to the normal in the window next. Is this forward or backward? Forward. Most definitely forward, yes? Because you actually have a number on the axis, which you can generate an area from. Does that make sense? Well, it'll make sense here in a second when we start drawing it out. So here's the pregnancy curve. Average, 1 standard deviation above.
It's gonna be right below 2.
Right below 1.
Right below one.
That's what's so interesting about this.
Yeah.
That's 282. This one falls at 280. 14 days above. That's the first thing that got my attention. I'm like, oh, damn. That seems like a hell of a lot of area, doesn't it? That seems like a hell of a lot of area for something that seems like an unnatural thing to do. That's what, hence my joke about the zipper earlier, right? Hence my joke about the zipper. If induction is such a natural thing to do, I would think that the body would invent something to make it easier. Say that again, Sarah.
Well, I'm thinking from the medical perspective,
And I'm thinking more like, I totally agree with you. I'm thinking more from Darwinian selection. That's, first of all, what is that? Let's figure out what that area is first. Then we can ask about whether we agree with it or not. So, what is this? Well, I don't know. We can figure it out, can't we? Susan, I want to use your formula. Because I got 280. I know the average is 266. I can convert this to a z-score, right? 280 minus the 266 over 16. Now, I know that's 14 days. That's what we just defined it as, 14 days above average. So it's 14/16. That's below 1 standard deviation. It's right about 88% of standard deviation, I think. That's 7/8, which is 87.5. So now you got your z-score. Now let's figure out where that is. Well, I don't know. I just wrote over the part of the word I want to draw. I'll put it over here, see how good my drawing is. Definitely forward, yes? We're going to the right. The left bound is 0.88. Not bad, actually. We drew it pretty well.
19%.
19%. I'm going to call that 20% just to make the math easier. 20% of births should be induced by this definition. Say that again. That's 1 in 5. That number is staggering to me.
But I believe it happens though, for sure.
I think it does too. But my question is, why is that? If all this is right, big if all this is right, 1 in 5 seems exceptionally high for a biologic system that seems to have itself figured out pretty well. Why should you have to interrupt a natural process?
Because we have a
1 in
bunch
5.
of other stuff to do.
Yeah.
Well,
My mother went 33 days overdue with me.
Who?
There was time then.
But you're
there was, I know. So she though. There's no. People don't have time to wait. I mean, we're planning on that date for them to come out.
okay, so you're saying 14 is a temporal thing.
It's society that's kind of made
Society,
it that way.
it's a societal temporal thing.
We have
Okay.
to go. We have to go. And
I got no
plan on
answer
the
for this.
baby.
I like to take some information. Jake, go.
Because biologically it doesn't have to self-figure out. Childbirth is really dangerous for basically every species ever.
Ah! What's the mortality rate of some species? You have any off the top of your head, like a chimpanzee? Any idea? But it's pretty high for like a primate species. It's a fairly high mortality rate.
Even in like cats and dogs, it's dangerous.
But humans are way more difficult to birth than any other animal because of the head size, the circumference.
Oh, damn! But hang on a second. Time out though. Time out. So this 2 weeks might be the fact if you go in more than 2 weeks, the head's going to grow that incremental amount more.
Everything
To make it
starts
back.
to go in
So
a
much
negative
different.
manner. The
Okay.
probability of
So we're seeing evolution happen basically, and we're I wonder if we're altering it by creating the induced labor.
We are.
And we have better outcome of birth.
Right, but I wonder if we're then altering that. Like if we're going to start changing, I don't know. I mean, it's geologic time or biological time. It's hard to measure as humans. Go ahead, Jake.
That's like say that would be if you're genetically predisposed to hold a baby for a certain amount of time, that it would be affected evolution. If it's just something that happened and babies aren't coming out.
Oh, I see what you're saying. I see what you're saying. I see what you're saying. It's after the fact.
Right.
It's everything. The development's already happened. It's after the fact. Okay, okay. So I'm still pushing for the zipper then.
You don't have a gene that says you can baby out now.
I got you.
We have a zipper, it's called pitocin.
We have a zipper. It's called pitocin. Genius. Thank you for that explanation, Jake. Go, Lauren.
You're not also taking into account what we now know about what we know about mothers and people who have medical conditions, or like the mothers who have medical conditions
Sure.
who can only go because for me, I have POTS, and if I ever get pregnant, I can't. The bigger the baby gets, the more strain on my heart. Baby's
Gotcha.
gotta come out like
What
right
is
away.
What is that?
Postural orthostatic tachycardia syndrome.
That was a lot of words.
I had
It sounded very long.
Postural.
It's a heart thing.
It's a heart.
It's a
I
heart
had
thing.
surgery like 2 months ago.
Sorry, math.
That's okay. but we also know, our technology is so much better to know more about the mom and to know more about the baby. If the baby has a certain issue that needs to come out and be fixed, you know what I mean? Like,
Sure. This
a lot
and
more.
that goes back to my evolutionary. If that happens enough over centuries.
Yeah.
Well,
We are altering it.
But like she said, there's also the mortality rate previously, centuries ago.
I did not know that. I did not know what you guys just told me about the idea of childbirth being basically across species being. I'm sure it's not at 50%, but it's a high enough percentage to be worrisome. So interesting. Thank you for teaching me. I appreciate that. I didn't know that. And this is all of this, friends, is based on this. Suppose I was off with this calculation. Suppose this wasn't 16, but it was instead 10. Suppose that was 10 instead of 16. 16 days.
Then that would be.
What would happen to our percentage? Gut feeling, no calculations. If the standard deviation were not 16, but were instead 10. Make it easier, make it 8, make it half. If it were smaller than 16, what would happen to the percentage? Assuming it was still 2 weeks past. So this was still 14.
The percentage would grow. There would be more.
Check this out, check this out. If that were still 14, but that were half of what it is now,
Yeah, it'd be a much bigger number.
what would that be?
What, double that?
Double what it is, which means the z-score would be double,
So we
which means it would go further out on the curve, which means the percentage would actually go down. That's a 244 lesson in 30 seconds right there for just FYI. Well, that's got something to do with 244 all the time. So you see how important it is to get the standard deviation right too. Remember, I extrapolated that from all the journals that I read. So before we get too up in arms about anything, I love getting up in arms about it because it means you guys are close to the topic we'll talk about it. But at the same time, it's all based on those numbers and the correctness of those numbers. And that's the beauty of it. When I do the Michael Phelps, Mark Spitz thing sometimes, that's wrong! Okay, tell me something else. I'm not saying it's right, I'm saying it's how I'm thinking about it. Does that make sense? So, that's as far as you can go. I mean, you have the accepted parameters you gotta use, so you're within those parameters. But at least you have a tool for it. Yeah? Cool. Now, I have an in-class quiz, but look at the clock. Rather than, if you want, I'll stick around right now. If you want to work on it right now, we'll stay till noon, like we usually do. If not, you can grab it with you, take it with you, do it over the weekend, bring it back on Tuesday. Up to you. It's bell curve stuff on speed limits in Portland. So basically, here you go. I'll hand these around. If you want to hang around, I'll hang around too. If you want to take off, take off. If you want to work on something else, work on something else. Just make this a 20-minute study hall, or someone just ask questions about, do that, do something else. Same thing out of the other class. Okie doke? Have at it, friends. We'll do the central limit theorem on Tuesday, which is freaking awesome. And our last topic.